Here we look at another alkyne hydrogenation reaction. This one, though, is a little bit different because it's based on the use of Lindlar's catalyst. So a typical hydrogenation of an alkyne using H2 and some sort of metal catalyst, most commonly we use palladium, results in hydrogenation to the alkene, and then finally all the way to the alkane. But in 1952 was the first disclosure by Herbert Lindlar of a different catalyst for this reaction. And it's not largely different, but there's a modification to it. And this reaction uses hydrogen again, but instead of palladium on carbon, we have palladium on calcium carbonate, along with lead oxide, and sometimes you may also see quinoline in here. What these extra reagents do is they poison or deactivate the catalyst. And so the result is that when we get to this point, where the alkyne has been reduced to an alkene, the catalyst is no longer reactive enough to go any further. And so what Lindlar's catalyst allows us to do is it allows us to start with an alkyne and stop the hydrogenation specifically at the cis alkene. So why the cis alkene? Well, we get the cis alkene for the same reason that the hydrogenation reactions we've looked at previously, whether alkenes or alkynes, give us syn addition. And that's that if this is our metal surface, the hydrogen becomes coordinated to the palladium, as does the alkyne. Then we get a transfer of one hydrogen over to that alkyne. And then the second hydrogen, as you can see in the way it's pictured in the drawing, when it's going to shift over and add, will also add from the same side. And so this gives us, regardless of our starting alkyne, a fairly easy way to make cis alkenes. And making cis alkenes, it turns out, is a fairly useful thing to be able to do. As we've talked about with alkenes, in most cases, the transalkene is more stable. And therefore, reactions that make alkenes, it's usually much, much easier to make the transalkene. So the use of a hydrogenation with Lindlar's catalyst is actually one of the easier ways to make cis alkenes specifically. And so you can see in each of these three cases, we started with an alkyne, and that alkyne ends up as a cis alkene.